We live in a world surrounded by wireless signals. Our phones, our computers, even our refrigerators can communicate with each other. But what if we could shrink the technology that makes this possible down to an almost unimaginable size? Enter the world of nanoradio. Nanoradio is a revolutionary technology that allows us to build radios so small they can fit on the tip of a pin. Imagine the possibilities. These tiny radios have the potential to revolutionize fields from medicine to environmental monitoring. They can even be embedded in everyday objects, creating a world where everything is connected. But how does something so small function as a radio? The secret lies in the use of carbon nanotubes. These tiny cylinders of carbon are incredibly strong and have unique electrical properties that make them ideal for building nanoscale electronics. In a nanoradio, a carbon nanotube acts as the antenna, tuner, amplifier, and demodulator, all in one. It's a testament to the ingenuity of nanotechnology. The story of nanoradio begins, as many technological breakthroughs do, in the laboratory. In 2007, a team of researchers led by physicist Alex Zettel at the University of California, Berkeley, made a groundbreaking discovery. They found a way to use a single carbon nanotube to receive and transmit radio waves. This discovery was met with excitement and anticipation. The potential of a radio so small was immediately apparent. Imagine medical devices that could communicate wirelessly from inside the human body, or environmental sensors that could be deployed almost invisibly to monitor pollution levels. The early nanoradios were relatively simple devices, but they proved that the concept was sound. Since then, researchers around the world have been working tirelessly to improve the technology. They have developed new techniques for manufacturing carbon nanotubes with the precise properties needed for nanoradios. They have also made significant strides in improving the performance of these tiny devices. The journey from a laboratory curiosity to a practical technology is rarely straightforward. Nanoradio has faced its share of challenges, but each hurdle has been met with ingenuity and a drive to push the boundaries of what's possible. One of the key challenges in developing nanoradio technology has been improving its sensitivity. Early versions of the device were not very good at picking up faint signals. However, researchers have made impressive progress in this area. By optimizing the design of the carbon nanotube antenna and developing new signal processing techniques, they have been able to dramatically increase the sensitivity of nanoradios. Another area of focus has been improving the range of nanoradios. Initially, these devices could only communicate over very short distances, on the order of a few centimeters. Today, researchers have extended the range of nanoradios to several meters and are working on extending it even further. This is being achieved through a combination of improved antenna design and more efficient power amplification. Section 4. A world of applications. Nanoradio's impact on various fields. The potential applications of nanoradio technology are vast and varied. Its small size, low power consumption, and ability to operate wirelessly make it ideal for a wide range of applications. From revolutionizing healthcare to enabling the Internet of Things, nanoradio is poised to have a profound impact on our lives. One of the most promising areas of application for nanoradio is in the field of medicine. Imagine tiny, implantable devices that can monitor vital signs, deliver targeted drug therapies, or even provide real-time feedback during surgery. These are just a few of the possibilities that nanoradio technology is opening up in healthcare. Beyond medicine, nanoradio has the potential to transform environmental monitoring. Imagine a network of tiny, low-cost sensors that can be deployed across a city to monitor air quality, track water pollution, or even detect earthquakes. These sensors could communicate wirelessly using nanoradio technology, providing real-time data that could be used to improve public safety and protect the environment. Section 5. Medical Marvels. Nanoradio's potential in healthcare. The human body is a complex and delicate machine. Treating it effectively often requires accessing its inner workings with minimal invasiveness. This is where nanoradio emerges as a potential game-changer. Its minuscule size allows for its integration into tiny implantable devices, opening up a new frontier in medical technology. Imagine a world where blindness is no longer a life sentence. Researchers are exploring the use of nanoradio in brain implants that could potentially restore sight to the visually impaired. These implants would bypass damaged optic nerves and directly stimulate the visual cortex, allowing the brain to interpret visual information once again. Beyond restoring lost senses, nanoradio could revolutionize drug delivery. Imagine microscopic capsules equipped with nanoradios, each carrying a precise dosage of medication. Doctors could remotely trigger these capsules to release their contents at specific locations within the body, targeting tumors or infections with pinpoint accuracy. Section 6. Overcoming obstacles, challenges and future directions. While the potential of nanoradio is undeniable, several challenges remain before it becomes a ubiquitous technology. Addressing these challenges requires not only scientific breakthroughs, but also careful consideration of ethical implications and potential risks. One major hurdle is the mass production of nanoradios. While laboratory-scale fabrication has been achieved, scaling up production to meet the demands of various applications remains a significant challenge. Researchers are exploring new manufacturing techniques, such as nano-imprint lithography and self-assembly, to make the production process more efficient and cost-effective. Another challenge lies in powering these tiny devices. Batteries are not a viable option for devices the size of nanoradios. Researchers are investigating alternative power sources, such as energy harvesting from ambient sources like light, vibrations, or even radio waves themselves. The goal is to create self-powered nanoradios that can operate indefinitely without the need for external power sources. Section 7. The Nano Future, a world transformed by tiny radios. As we stand on the cusp of a new era in wireless technology, nanoradio offers a glimpse into a future where the impossible becomes possible. Imagine a world where everyday objects are imbued with the ability to communicate, where medical treatments are minimally invasive and incredibly precise, and where environmental monitoring happens seamlessly at a microscopic level. The journey from the laboratory to our daily lives is well underway. Researchers, engineers, and entrepreneurs are working tirelessly to bring the promise of nanoradio to fruition. As the technology continues to evolve, we can expect to see new and innovative applications emerge, transforming industries and touching every aspect of our lives. The future is nano, and it's a future brimming with possibilities. As we continue to explore the frontiers of this exciting field, we can look forward to a world made smaller, smarter, and more connected by the power of nanoradio.